All right. Usually I would be joining you from the west coast of Sweden, but I'm out on an adventure, client work. So I am actually in well, near the capital of Sweden. So I'm very close to the east coast at this point, but it doesn't matter. When you signed up to do a meetup, you do it in the morning. Um, so currently 8 a.m. over here. Good timing, actually. All right. So this is a talk about traces. I guess people have heard about open telemetry. Show of hands, who knows about open telemetry and traces? Uh, it's nice that I can see the crowd. This is very helpful. And I can see Zoom hands. That's good. We're not talking about open telemetry traces at all. This is not what this is about. We do Erlang tracing, which is much older than open telemetry tracing because Erlang is like 40 years old very soon. And it has its own tracing facilities. They're much cooler. Again, might cover this. I run underjord.io. If you've seen this beat, this pink and teal thing around, that's me. I have a small team. I publish a bunch of things. Moving on. So Erlang's tracing is a way of using the beam abstractions. And this is like standard Erlang things. We design something with a slightly higher abstraction level, which allows us to do something really difficult. So it allows you to do runtime introspection of pretty much everything that the system can do. So it's this flexible and far-reaching observability tool. And I don't think most developers know about it. Like maybe a show of hands, who has used Erlang tracing? I think it's a one. One. Okay. Yeah. Pretty much what I figured. So many don't know about it at all. Others don't know what it could do for you, so you don't look into it. And then it's also hard to get started with the built-in tools. But what it allows you to do, for example, is to see function timings, the arguments a function was called with, return values, exception values, and much, much more. And you get to do it at runtime without redeploying, without adding extra instrumentation. You can just do it. So we have everything we could possibly need. This is the Erlang fundamental API. So you need to do 2 calls and then you can get some traces. Absolutely trivial, right? Very straightforward. We can go through it just like I know everyone completely understands what this function is all about, but let's go through it anyway. So it's in the Erlang standard library. The function is called trace. I think that's a fair enough name. Now, the atom all, and that tells us that it will trace all existing processes and any that will be created from here on. True indicates that you want to switch tracing on, not off, which is perhaps not obvious. And then these are some options that you can pass to Erlang trace. In this case, we want to trace function calls, we want timestamps, and we want them to send it to the tracer process self. So we just want them as messages to our current process. Okay, fair enough. Then we get to this, which is the Erlang trace pattern. So what are you tracing? Because you don't want messages about every function call in your application. This is how you get a crash or significant slowdown because you're filling your system with trace messages. No good. So you set a pattern. And in this case, we trace the queue module from Erlang, the function new, and the arity 0. Pretty straightforward. It's an MFA, module function arity tuple. I like those. Those are good. You can also use the atom underscore as a wildcard, which is kind of convenient. So you can skip the function and the arity, or just the arity if you like. Then we get a match spec. This is also a good crowd question. How many of you have written match specs? One. Got it. Match specs are cool, but tricky and annoying. They are how you can do fancy queries in both EPS and I think Amnesia. They also let you decide how your trace patterns work and do really nice fine-tuning of your traces. But you can get really lost in them. Like this, to me, is not very obvious. So I think it matches for any incoming argument, and then we want to send a few types of messages to with additional information along with the trace. Yeah, it's a little bit of a mess. There's a lot of documentation to it, but it's not all that clear. And then we have this option local, which does not mean the local node. It means something entirely different. Global would mean that you only hit functions that call out to other modules. Local will also hit local function calls, which means when you're calling internally within the module. There are 4 more options to trace pattern. We're not going to cover those at all. So this is what you would get. You would get messages with this shape from this these 2 functions we just did. So you get trace with a timestamp is what trace TS means. We get to know which PID it was running in, so what process actually made the call. We get 2 messages because it's both a call and a return value, because we asked for return values. We get to know what it was called with, so Q new and an empty list, so there was no argument passed. And because we asked for it, we also get to know where it was called from. So in this case, trace talk.sampler handle continue to. And then this last thing with the tuple with the numbers is a Erlang timestamp that you can change to a proper timestamp, which you can deal with. You also get the return value down here, the return trace. So it's also cool. So why are there 2 functions? Why is there not just one function call that gives you all this? And why are they so complicated? So the initial one, trace, sets up the required upfront config that you can't do at pattern matchy tracey time. So then we have trace pattern, which allows you to really configure what messages do you want, because there might be a lot of noise coming from a particular function call. You might just care for a specific criteria. So these are super powerful primitives, and it allows you to build great tools on top of them. So that's when we get to higher level abstractions, because no one can remember how to write match specs. Just a sip of water. So DBG, this ships with Erlang, the text-based trace facility. So it has a different API. You start a default tracer by doing dbg tracer. You can start exception tracing by doing dbg.tp q new, and then X stands for exception, of course. Kind of obvious, I'm sure. And then they tried to make match specs fun. I don't think dbg fun to ms really worked under Elixir, or there was something weird when I tried it. But I didn't find that it did make match specs fun. It might make them simpler to write under Erlang, but so DBG tries to be something quite different from the normal trace facilities. It has these very terse function names, and I think it's very much intended to be a debugger. If you would use debuggers, they very often have very, very terse commands like P, D, T once you get into them. And for me, I rarely use tracing. I use it when I have a problem that I'm trying to investigate sometimes. And trying to remember how to do any of this at the time of an incident or at the time of troubleshooting a production system at all is annoying. I would say DBG is friendlier and simpler than the Erlang primitives, but it still wants a bunch of match spec stuff to do most things. And as far as I can tell, it doesn't seem to put any safety in place to prevent overloading the system. When I presented this at Meta in Stockholm, there was some bunch of Erlang folks there, so I got some really cool feedback. But they said that DBG had some facility for safeties, but I don't recall exactly what it was because it was in person. Yeah, not super impressed with DBG, not something I would personally use much, but it's there, it's fine. I'm sure it's good for some people. If you know how to use it, I'm sure it's good. Redbug. This is an Erlang library that's very popular. An Erlang tracing debugger. So much simpler. To start a basic trace, you do redbug.start and the string q:new. So that looks like Erlang code inside of a binary string. You can stop the trace. You can run redbug start and include an arrow to return or a return and stack to get the return value trace as well, or the return value with the stack trace. And Redbug has some built-in safeties to prevent yourself from causing trouble. So we can do a, let's see, this is the one, yeah. We can actually just do a quick demo of Redbug here. Return, let's be fancy. So this is a demo project where the trace talk sampler will run q:new every couple seconds. So here we get the traces printed, which is interesting. There are, to all of these types of tools, there are typically a bunch of options depending on how they are intended to be used. So here we can see that Redbug considered that we had a timeout. So I think it was, I'm not sure if that means 3 traces or 3 seconds between tracing. Anyway, it has limitations. It will not keep going for eternity, which saves you from accidentally murdering your system using Redbug, which is nice. Something the Erlang folks definitely mentioned is avoid tracing all functions or avoid tracing IO functions, because if your, for example, Redbug uses the IO process to output the traces and you trace the IO function, you get an eternity of traces. So it is a tool which you want to be a little bit careful with. You can absolutely grind production to a halt using it. So Redbug, it has clear function names. Start and stop are pretty straightforward. It has simple conventions. You give it a string, and the syntax of those strings is pretty straightforward. So you don't need any match specs, which I like. I can't really remember the strings. Now, they are very close to Erlang code, so I don't think this is a problem for Erlang developers. I'm an Elixir developer mainly. I don't find it very discoverable. So you can't kind of tab complete your way or just help doc your way easily to what you should be doing while you're in the IEX prompt. And like the Erlang syntax will trip me up, but it does have built-in safeties. Redbug is very usable. You can just plug it in and it's gonna be of use to you. Recon trace is part of the recon package. Also, functions and scripts to debug Erlang in production. Recon has a bunch of cool tools. You might want to add Recon to your project regardless of whether you think you need the tracing or not. So the simple case is recon trace.calls, and then you give it an MFA for the pattern, and then you give it the limit of the number of traces. And you have to give it a limit. So it has this built-in safety. It will never trace more than explicit asked for number of messages. If you want to configure recon trace to do something more fancy, you end up needing to do match specs. For making that simpler in Elixir, you can import ex2ms, as I've done in the sidebar here, which lets you use macros to generate match specs, which kind of feels like doing function calls and pattern matching. It's better than doing match specs any other way under Elixir, but I still, yeah, not a super fan of match specs. So we can also demonstrate recon trace. So here it is. You should probably not use all of these at the same time, because up until recently, there was a limit. Like you could only have one active tracing tool at any one time. And this is apparently changing in OTP 27, so that's interesting. So yeah, you're getting the traces. But if you want return values, you suddenly need to do something match spec-like. But overall, like Recon Tracer is an improvement on top of the Erlang trace facilities. It's much simpler. It has clear function names, simple conventions. It uses MFAs. I like those, as I mentioned. Still use the match specs, which I can't remember. So I will need ex2ms to survive. And I almost don't remember how to use ex2ms day to day. And the Elixir wrapper that is most obvious, Recon EX, seems to be outdated. It doesn't build on recent versions of Elixir or Erlang. I don't recall exactly what the problem was. It comes with built-in safeties, and you should probably just include Recon in your app because it's useful. Then there's eDBG, which is more in the school of DBG, a simple TTY interface to the Erlang debugger and tracer. So, for example, if I call eDBG fstart with a pattern, it will start tracing, and then when I call stop, fstop, it will stop tracing, and then it will have saved a file, which I can then start an interactive session against. This is not how I think about tracing typically, but my attention was called to this because when I announced I would be talking about tracing earlier, the creator of eDBG reached out and mentioned the project. I think if you like debuggers, you will probably like eDBG. It seems quite evolved. It seems to have a lot of features. It wasn't kind of what I am looking for in tracing, and I found it a little bit confusing. So I think there's a bit of a learning step to it. But yeah, look into it if you like debuggers. This one was called, my attention was called to this very recently. So shout out to Lost Cobra Kai for pointing me at Xtrace, which I had completely missed. And it is currently working front-end or Elixir wrapper for Recon Trace. So the API is very similar. And you also end up needing to do match specs if you want to get fancy, or it does some variant on match specs. I didn't quite follow how it worked. I didn't dig deep into it because I haven't spent much time with Xtrace, but it seems like a good kind of default option to pack into your app if you want tracing functionality. And it has a lot of options that made it seem very flexible, but also a little bit complicated. So why am I talking about tracing at all? Well, I really like tracing. I think it seems like a superpower of the beam that we don't use enough. And as such, I decided to try my hand at making it more approachable, which meant I built my own library. So my library has probably worse starting than anything else that I've showed so far, which is kind of dumb in some ways. But if you then want to trace, you start your Gen server, and then you want to trace, so you pass in a pattern. I like MFAs, so I went with MFAs. And then you have a few options for what you could do in terms of capturing the trace. I can pass self if I want them as messages. I can also pass function. So I could pass IO inspect here if I like. I'll go with self. Here we also get some debug logging while the tracing is happening, which is because I have debug logging on, not any other reason. But we can flush to get the trace. And if we look at what the trace is, it is a message, trace message, which contains a trace struct. And so this is kind of an opinionated library in that it takes the data and it builds you a proper struct. You get the MFA with the arguments, you get which PID it was, you get when it was called at, when it was returned at, and these are converted to proper timestamps. You get the return value or exception value. You get stack trace by default. You get the caller. You get the caller line. So you get a lot of information by default. And I've optimized the trace to focus on function calls. So let's talk a little bit about trace. So for the primitive use of it, you start it with start link, and then you can make calls to it like this. So having an explicit starting of the trace listener is intended to give you practical primitives that we can build cooler things on top of. I hope to give it reasonable function names. So the only thing you really call when tracing is .trace or .trace cluster if you want to go across your entire distributed cluster. It uses MFAs because I like those. And there's a bunch of options for passing a PID or a callback or an MFA for what you want to do with the trace. It includes a bunch of options that I think are what you typically want by default. So it's timestamps, it's return values, it's exceptions, it's the caller information, it's the stack trace. It has built-in safeties. It will process by default 200 messages and then be done. And you can also set a time limit, or you can set both a time limit and a message limit. You get a proper struct back, so you can know which data format you're getting, which also helps when building tools on top of it, but it also just helps when working with the output. And I had not heard of Xtrace when I named it ntrace. I just thought it sounded cool. But that start link is a little bit annoying. So I used a common pattern in Elixir. There's a tracer module. So for your app, you can define a module, app.tracer. You call use and trace.tracer. And if this pattern seems familiar, it's also used by Phoenix PubSub, Ecto repos, Promex, many other things. And then you get your app.tracer module and just shove it into your supervision tree in your application. And then you can call app.tracer.trace or app.tracer trace cluster anywhere in your app. You're essentially creating a singleton on every local node. So when I wrote this talk originally, you can't have multiple tracers active at once. So having a singleton is actually kind of appropriate. But now they're changing that in OTP 27. I'll have to think about whether I want to make any changes to the library due to that, because it would allow some more flexibilities. It doesn't necessarily mean that the language or the library design needs to change much, but It's interesting that they're making that change now after many, many years of a single tracer. Yeah, needing to reference a name or a PID constantly kind of sucks. But having secret processes or like Erlang applications that spin up in the background is also not what I find ideal, which is what I think most of the tracers do. And we're using a common pattern in Elixir. So my hope is that this is the path of least surprise for any Elixir dev. It's like, oh, yeah, this is how Ecto works. This is how PubSub works. It also should let you auto-complete your way to success in IEX. It's like, oh, I need to use the tracing module. How did that work again? Okay, it's my app dot tracer dot tab tab tab. Oh, trace or trace cluster. Oh, I want a trace cluster. And then you can go. You can also do H on your module and get the help, the compiling help, of course. You can run multiple patterns simultaneously. Some of the other libraries probably allow this. Not all of them do. But you can have multiple traces. At the same time, you can pass options for limits or time limits, as I mentioned. You can also pull list trace info, and this I consider a bit of an experimental thing. There's a bunch of interesting, weird tooling in Erlang for call counts, memory, and timings, but I got really weird results. I got very mixed results. So I wouldn't kind of trust this yet, but it's quite interesting. So getting call counts and memory allocations for a particular set of function calls is super interesting and could be super powerful. But it's, yeah, it was a bit odd, and the API is odd, and the documentation is sparse. So I've spent a lot of time in the Erlang docs building this. It's been fun, but also confusing. I actually also made 2 libraries. So let's see, we have another demo. We need to break out to the browser. So I wanted to make this approachable for Elixir devs that are not deep into Erlang or anything. And I figured Live Dashboard is one of the best on-ramps to digging into OTP. So here we have it. This is kind of simple at this point, but if you want to trace anything that's happening with gen servers, you can just, underscores are fine. Let's go start trace. Then you can, I want to know what's happening, the files, start trace. And you get this table as the data comes in, which you can sort, you can search, you get the return values as a representation, you get the timings calculated, how long they took. So if you have a slow function that's only really slow sometimes, you can see which arguments, which outputs it has when it's being slow. And you can also, of course, then dig in and go look in your code and like, oh, it's calling this function. I wonder if that's the slow part. Okay, let's add that to the trace. So this will trace your entire cluster and just feed you with whatever is happening. And these patterns get removed as they trip their limits, and you can always add new ones. So, and we also get a little bit of autocomplete, which is just this using like the HTML data list stuff. There. So yeah, there's a Phoenix Live Dashboard. It's still kind of crude, so if anyone wants to contribute improvements, that's very welcome. There's more I wanted to do, but I wanted to prove to myself that this is something you can do. I wanted to get people's feedback on whether they think you all think it's useful. So I want to expose the tracing to Elixir devs who don't necessarily live in the shell. I think it makes for a very practical tool for just looking into function calls and timings without necessarily popping a shell on your production system. You just go to your web UI and type some stuff in. And it plugs into your default Phoenix tooling. I think it's one of those really interesting demos of what Erlang can do that almost no other ecosystem can do, and what Elixir can make easy that Erlang kept hard, honestly. It was also inspired by Orion, which is another project you should just jam into your application as soon as possible. That uses tracing to do distributed profiling. So it's very focused on timing and histograms, but it's also using a live view web UI that you just plug into your routes. It's by Thomas DePierre and one of his friends. So you should look into Orion if you're interested in this stuff as well. And Orion in turn. So it's not new to try to build kind of higher level projects on top of tracing. So Orion took its inspiration from XProf, which is a cool Erlang project that does essentially a web UI for distributed profiling. XProf doesn't run under recent versions of OTP, so it seems a little bit abandoned. And then there have been assorted ways of trying to visualize Beam projects. Some of them use tracing. So if anyone wants these slides later, just let me know and I'm happy to share. And also in Livebook, we use tracing for message passing, which is another thing tracing can do. You can listen to messages. You can look at when processes spawn. And it's used to visualize supervision trees. So what else could we do with tracing? Well, message sending and receiving, there's tons you could do with that to either map your system or follow some particular logic. There's a lot of weird features for fine-grained tracing of spawned processes. There's something called sequential trace, which means there's a token being passed around between processes as they interact. It's super trippy to read about. So I think there's a lot of mapping you could do, for example. And I'm also curious what could be done automatically in response to, well, we have a service exception or we're sampling certain requests and occasionally turning on tracing, that type of thing, to detect problems and maybe even drill down into them. There's a lot you could explore there. And I keep asking myself, kind of, what would a New Relic or a Honeycomb or a Datadog look if it was built for the Beam, not just serving Elixir as another pluggable language. Now, and Trace, last time I gave this talk, and Trace was still just on my GitHub. Now, and Trace has been released. It's a 0.1, so be a little bit careful, but please do use it, give feedback, send issues. It's available on Hex as ntrace, and a separate live dashboard isn't available as ntrace live dashboard. The GitHubs are under Jord. And thank you for listening. Happy to take any questions.
All right, thanks very much, Lars. Let's take questions from the room in Sydney first.
Yeah, we've got one question.
Yeah, just when you're talking about match specs, you're also talking about the Erlang string syntax caught you up. What? I'm ignorant of it. How is it not fun?
Oh, was that just childless? Did you hear that, Lars?
I did not hear the question, so if you can repeat it, that would be helpful.
So you were talking about match specs, but then you said the Erlang string syntax, which I'm assuming you meant child lists, tripped you up. Is that what you meant?
Yeah, so sometimes I get tripped up by the fact that for example, Redbug requires you to write essentially a string of Erlang-ish syntax, which is not typically what I have in my head when I'm writing Elixir. But I think I heard something about whether something was fun, and there was a bad joke in there about the dbg.fun to ms.
Oh, yeah, yeah.
Yeah, they have a function to match spec, which yeah, it did not make match specs fun, was my point.
I didn't
Does
get that joke.
answer
Now
the
I got it.
question? No, I have no beef with the Erlang syntax beyond I don't really know it and I'm not comfortable with it. I don't find it super helpful for what I'm trying to do as an Elixir developer. And I don't like match specs because I find them confusing. It's not that they're bad, it's just confusing.
You were just being accused by Kip of being un-Swedish.
Oh yeah, yeah. Overall, I get along with the Swedish Erlang contingent, but like we've had discussions. Okay.
Any other questions? None here. Are there any online?
Look, I do have a couple, but I'll invite everyone to drop your questions in the chat and then I'll relay them to Lars, or Lars can read them off. But while we wait and see if anyone else does ntrace support tracing process crashes? Because I'm thinking that the one use case that I would definitely have for something like this is if someone is using a live view and they're trying to interact with a form, and the live view keeps crashing and restarting and their form is reset.
Right.
It'd be great to be able to just see exactly what's the event and what's the process state that's causing that live view to crash and reload without telling the user.
So, and trace focus on function call crashing, but if you have something that's crashing, that's happening in a function call typically. If it's a background type crash, like tracing could absolutely trace what's happening to processes. But in this case, I would say you could probably just trace handle event on that specific live view.
Mm-hmm.
And if that causes an exception, then you kind of have your culprit there. You'll see the inputs, you'll see the exception output, and yeah.
Nice.
So that would do it, I think. I have a question to the room as well. Is anyone going to try this? And this is also, of course, me encouraging you to try this. How many here have a Phoenix project that they work on? Okay.
Yeah,
Because
I think
anyone who has a Phoenix project on a fairly reasonably recent Elixir or live view should be able to do this. And if you find that it doesn't support, the library doesn't support your version of Elixir or version of LiveView, let me know, because we can probably just tune that way back. I haven't even explored how old the support could be, but yeah.
Yeah, I think the live dashboard, Lars, was definitely made the tracing very attractive, because that is
Yeah,
just
and I
an easy
definitely
way
want
to
people
interact.
to help add to that, because there are more things to do. It's like, oh, maybe I want to remove some of the traces before they finish. And there's lots of UI niceties and making sure that the form doesn't refresh while typing. There's things to improve. It's like 0.1 for a reason. But it's definitely usable and it should be fairly safe. So.
Also, I think the name not having an EX in it is a feature.
Yeah.
But well done.
Thank you. I believe my original inspiration was kind of zoom and enhance, from bad crime movies, and trace and stuff. So, yeah.
Sorry, Doctor. Get into sort of a thing. What's the system?
Did you cover sys module? I don't think you did, but I may have missed it.
No. Is there an additional tracing variant in there? There might be. I did not cover sys, but I seem to recall having used it at some point. Trying to figure out what is available in the Erlang libraries. And like, there's clearly been a bunch of runs at making tracing nicer. Maybe I should look into the sys module as well. This is not a perfect history of Erlang tracing. I would need to talk for a long time with some very opinionated people to get the full idea there. But they're available. They're right in Stockholm, most of them.
Would it be a misuse of tracing to use it in a test? Could you just to confirm that a function was called, a bit like you might use a mock or a spy?
Oh, whether it's a misuse, that's very philosophical. Actually, I think that would be perfectly workable. It's like, yeah, you can absolutely, like, it can fight you if you actually use mocks a lot, because then maybe you're not supposed to look into the system further down the line. But if you're not precious about that, yeah, I could see using tracing just to set that kind of thing up. It would affect your ability to, or would it? Actually, since you can run a bunch of different patterns, it might slow down some tests because the gen server is a little bit of a bottleneck potentially, but typically it wouldn't be. And yeah, no, that could totally work. I think that would be absolutely workable. Deviant.
Mike, are there any other questions online?
No, last call for questions online. I'm not seeing much come through in the chat. You're all blown away. Installing it
it's
right now.
fine to reach out on like LinkedIn or Mastodon or email. Underjord.io, you can find most of the ways to reach me. I'm fairly available, so just reach out if you have questions. And the issue tracker on any of these projects will be appropriate for any concerns or questions or discussions as well. I'm a little bit slow on GitHub because GitHub's notifications are either all on or all off, it seems. It's just weird. But
Oh, I had one
yeah.
more question. You talked about
Yeah, go
Orion
for
a
it.
little bit, but you didn't really say what it was. If I ever knew what it was, I'd forgotten. Can you just describe that a little bit more, Orion?
So we can bring it up here because I think there's a screenshot which is helpful. So you might recognize the idea of a module function and an array at this point. But this is a project that you can add to your application where you get these histograms and it traces across your entire cluster. And you essentially, you configure live view mostly. You make sure you have a socket, yada, yada, yada. There's a particular route you add to whatever scope you want, and then you get Orion. And it is all about measuring performance. So yeah, it does percentiles and it does histograms. It doesn't tell you whether something did good. It doesn't tell, like, and trace very much focuses on function calls and trying to get at what is going wrong or what is happening in here specifically in the small. And this is like, oh, maybe you're having a lot of traffic and you're seeing weird outliers. Where are they? Are they in this function? Are they in that function? So yeah, it's more of a performance tool. But Orion is definitely something I would suggest looking into. Find it. It definitely inspired this, and it's very cool. So.
Yeah, nice. That looks very good.
All right, I'll hand off the screen share.
Thanks again, Lars.
My pleasure. Thanks for having me. Now I gotta run. Nah, actually, we wrapped very much on time, but I have a client engagement. So enjoy your pizza and like pub round and all of that. My day just started.
Well, enjoy the rest of your day, mate. Thanks for dropping by.
Take care. Thanks for having me.
Thanks, Lars.